Welcome to the project demonstration of a novel single phase 9 level transformerless photovoltaic inverter. So here we are going to design an inverter without using any transformer. So the transformer purpose in real time step up purpose. So nothing but we are going to provide the pulse input to a MOSFET circuit, that is the HV circuit. Here we are using the MOSFET, so which will convert the DC to pulsating AC, nothing but. So we are going to get the 12 volts DC input and we will get the 12 volts AC output with 50 hertz of frequency, and that is sufficient to on this the frequency is sufficient to on the load, but we need to more voltage, like 12, not 12 volts AC, we need 230 volts near 3. So but in our project, due to losses, we are going to get around of 200 to 240 volts based on the load which we are connected here. So the inverter which we developed can control maximum of 50 watts, so not more than that. So here the flow is, we are going to provide the 12 volts 20 watts power from this solar panel. So that was given through this charging circuit. So the charging circuit consists of 4 diodes. So the main purpose of the diodes is in generally real time bridge rectifier, so which will use it to convert AC to DC, but we are providing DC power supply. So now these 4 diodes will act as a polarity corrector. So the purpose of this polarity corrector means if we connect this solar panel in reverse bias, then this polarity corrector will correct the plus to plus, minus to minus, so that output given to the capacitor. So that is capacitor just will remove the ripples, and after this capacitor there are the 2 diodes are connected in series. So the diode purpose is whenever the battery is fully charged, so whenever there is no sunlight, so then the battery is going to be the high potential, the solar panel is a low potential. So obviously the current will flow from high potential to low potential. So then the solar panel will get damaged. So in order to protect that solar panel, we have connected the diodes in reverse bias. Means whenever the battery is fully charged, so the diodes will block the current from the battery to the solar panel. So the diodes will allow only current from the solar panel to the battery. So after that, the voltage from this solar panel charging circuit is given as input to this boost converter. So this boost converter consists of 2 MOSFETs and 1 inductor and diode with 1 capacitor. So the purpose of this is actually a buck boost converter. So the purpose of this buck boost converter nothing but, so whenever the voltage is above 14.5 volts, so we are using 12 volts solar panel, it may provide maximum of 18 volts. So then in order to doing the buck operation, we are going to use the buck operation from the circuit. So the buck will be done from 18 volts to 14.5 volts, and whenever the voltage is below 12.5 above 8 volts, then this circuit will do the boost operation. So that will be done with help of our PIC microcontroller. So here we are using the 2 voltage sensors. So these 2 voltage sensors will check the input voltage from this like solar panel charging circuits, one is, and another is output from this buck boost. It's a closed loop buck boost converter. So it will check the voltage from the charging circuits, whether it above 8 and below 12.5, then it will do the boost operation. If it is above 14.5, it will do the buck operation, and after that the output was given from this circuit. So this was to the battery. So the battery voltage will be charged after this boost converter and will given to the HP circuit. So the HP circuit will convert 12 volts DC to the 12 volts of AC, and after that, so using this inverter circuit directly we are going to step up with help of this 2 inductors and 1 capacitor is connected over here. So these MOSFETs are used to again providing the pulses to these inductors as they are using as a storage and discharging purpose. So then we are going to converting directly 12 volts AC to 200 to 240 volts AC directly. That was given to this load. So here we have interfaced these 2 voltage sensors at A0 A1 pin, and these 2 MOSFETs interface at C0 C1 and C6 C7 for this H-bridge circuit inverter H-bridge circuit. And next, let us see the demonstration. And ratings of this battery is 12 volts 2 amps. So its battery pack consists of 2 battery packs are connected in parallel, and 1 battery pack consists of 3 4 volt 1 amp batteries are connected in series. So we will get 12 volts 2 amps. So for charging this battery from the sunlight, you should place this under the sunlight, then only the battery will get fully charged. and after that when we switch on the cage, the microcontroller start working and it will provide the output directly. As of now we are demonstrating this with the help of battery. So if you place a solar panel, the battery will get charged directly from the solar panel with the help of the microcontroller by measuring the voltages and controlling the input and output voltages. So when we switch on this cage, the controller start producing the pulses to the H bridge and directly it will given to the load. Right.